Hello and welcome to another video from Adams Academy, an expert online tutoring service for high school mathematics. In this video, we are going to work out problems that appeared in the 2014 CBSE question paper from the lesson Surface Areas and Volumes. We start with a 1-mark question. A rectangular sheet of paper 40 cm by 22 cm is rolled to form a hollow cylinder of height 40 cm. The radius of the cylinder is. So we have a rectangular sheet of paper that looks like this, and the dimensions are 40 and 22, and this is rolled to form a hollow cylinder. You get a cylinder like this and the height is 40. You need to find the radius of the cylinder. So if you think about it, you'll understand that the circumference of this base is going to be the length of this rectangle, because you are rolling it like that. You are bending this and this end of the rectangle towards or in this direction, and you are bending this end in the other direction to form a cylinder. So the circumference of this circle is going to be this length of the rectangle, right? So you can say if the radius of the base is r, you can say the circumference 2 pi r is equal to 22, right? So if you use pi is equal to 22 by 7, 2 into 22 by 7 into r is equal to 22, and if you simplify, you will get r is equal to 7 by 2 or 3.5. So A is the right answer. A 5-meter wide cloth is used to make a conical tent of base diameter 14 meter and height 24 meter. Find the cost of cloth used at the rate of rupees 25 per meter. So we need to make a conical tent. Let's try drawing a cone. So there's a conical tent that looks somewhat like this, right? And the conical tent has a base diameter of 14 meters. So this radius here is 7 meters and height is 24 meters. So it's just height and not slant height. So this is the height that's given, that's 24 meters. Find the cost of cloth used at the rate of rupees 25 per meter. It's not really clear in the question, but let's assume that no cloth is laid on the floor of the tent. Okay, so we need to find the curved surface area of this cone, which is pi r l. To find the slant height L, you can use Pythagoras Theorem. So L is going to be root of 24 squared plus 7 squared, which is 25. So the curved surface area is going to be 22 by 7 into 7 into 25, which is 550 meter square. Okay, so we have a cloth that's 5 meter wide, right? And we need an area of 550 meter square. So the length of the cloth is going to be 550 divided by 5, which is 110. So we need 110 meters of cloth. Find the cost of cloth at the rate of rupees 25 per meter. So to find the cost, you have to multiply the cost per meter by the total length needed, which is 110. The cost is going to be rupees 2,750. The next question is also for 3 marks. A girl empties a cylindrical bucket full of sand of base radius 18 centimeters and height 32 on the floor to form a conical heap of sand. If the height of this conical heap is 24 centimeters, find its slant height. Correct up to 1 place of decimal. Okay, so first we have a cylindrical bucket. The bucket has a base radius of 18 centimeters. So this radius is 18 and height is 32. So the volume of this cylindrical bucket, or the volume of sand in the bucket, because the bucket is full of sand, is going to be pi r square h. That's the formula for volume of a cylinder. So that's pi into 18 squared into 32. That's the volume of sand. Now this sand is made into a conical heap. So the volume of the conical heap is going to be the same as the volume here, right? So you can say pi into 18 square into 32 is the same as, it's a conical heap. So the volume is 1 by 3 pi r square h, right? So 1 by 3 pi, you don't know the radius of the cone. So let's just take it as r. The height of this conical heap is 24. So h here is 24. From this equation you can find r. If you solve this, if you simplify this and solve, you will get r equals 36 centimeters. So for the cone, the radius is 36 and the height is already given is 24. And you are asked to find the slant height. You know that the slant height of a cone is root of r square plus h square. That is root of 36 square plus 24 square. So 36 is actually 3 into 12. We're just trying to simplify. You need to find the square root of this number correct to one place of decimal. So it will help if the number is small. That's what we are trying to do here. So 36 is 3 into 12. 24 is 2 into 12. So this is going to be root of 12 squared into 3 squared plus 2 squared. That's going to be 12 into root of 13. Now the only task is to find root 13 correct to one place of decimal. To find root 13, you need to use the old method of finding the square root manually. So write 13. 13 is going to be 3 into 3. It's 9. It's the remainder of 4. 2 times 3 is 6. Let's try 66 into 6. That's going to be 396, right? So remainder of 400. It's going to be 72. And the next digit here is going to be 0. In order to be sure of our accuracy, you need to find the square root to at least 3 decimal places. So I think this is going to be 5. So 5 times 7205 is going to be 36,025. And the remainder here is going to be 3975. So you can approximate that to 3.61. And 12 times 3.61 is 43.32. So if you round this off to one decimal place, this is going to be 43.3 centimeters. That will be the slant height of the conical heap. A hemispherical depression is cut out from one face of a cubical block of side 7 centimeters such that the diameter of the hemisphere is equal to the edge of the cube. Find the surface area of the remaining solid. So we have a cubical block side of 7 centimeters and a hemispherical depression is cut out from one face of this block. Let's assume it's the top face. And the diameter of this hemisphere is equal to the edge of the cube. So the diameter of the hemisphere is equal to 7 centimeters. Right? So the top surface of the cube is now going to look like this. You have a hemisphere that's carved out from this face of the cube. And the diameter of the hemisphere is equal to the edge of the cube. And since the diameter of the hemisphere is 7, it has a radius of 3.5. So the hemisphere goes down into the cube up to a depth of 3.5 centimeters, right? So that radius is 3.5. Now you need to find the surface area of the remaining solid. So if you imagine the remaining solid, it will have 4 faces on the 4 sides. And by 4 faces, I mean the 4 lateral faces of this cube. And then there is a face at the bottom which is not disturbed by carving out this hemisphere. So the 4 faces on the sides and the bottom face will remain as such even if you carve out the hemisphere. So you have the area of those 5 faces as 5 into a square, where a is the edge of the cube. And for the top face, let's just redraw the top face. If you look from the top, your solid will look like this. Here is the original face of the cube. Then you will have one circle like this. This is the top face of the hemisphere that's carved out from the cube. So in the remaining solid, you will have these four corners and you will have the hemispherical cavity. The surface area of this cavity is going to be 2 pi r square, because that's the curved surface area of a hemisphere. And now we need to find the area of the region shaded in red. How will you find this area? This area is going to be area of this square. See, each face of a cube is a square. In this case, the side of the square is 7. So the area shaded in red is going to be area of the square, which is 7 square, minus area of this circle. Area of the circle is pi r squared, and r is 3.5 because the diameter of the hemisphere is 7 centimeters. So that's pi into 3.5 squared. So the surface area of the remaining solid is going to be 5a square plus 2 pi r square plus this quantity. So that's going to be 5 into a is 7. So that's 5 into 7 squared plus 2 pi into r is the radius of the hemisphere, which is 3.5. So that's 3.5 square plus this area shaded in red color. That's going to be 49 minus pi into 3.5 squared. If you do these calculations, you will get 332.5. And here is the last question for 4 marks. A metallic bucket open at the top, height 24 centimeters, is in the form of the frustum of a cone, radii of whose lower and upper circular ends are 7 and 14 centimeter respectively. Find the volume of water which can completely fill the bucket and area of the metal sheet used to make the bucket. Let's try drawing the figure. So this is obviously a frustum of a cone. That's what the bucket looks like. It's open at the top. Height is 24 centimeters. So this height is 24 centimeters. And the radius of the lower circular end is 7 centimeters. So this radius is 7 and upper radius is 14. Here you have a radius of 14 centimeters. Find the volume of water which can completely fill the bucket. So that is the volume of the bucket. So you know that the volume of a frustum of a cone is 1 by 3 pi h into r1 square plus r2 square plus r1 r2. So in this case it's 1 by 3 pi into 24 into r1 is 7, r2 is 14, r1 r2 will be 7 into 14. So if you do this calculation using pi equals 22 by 7, you will get, this will be 8624 centimeter cube. So that's the answer for the first part. Now we need to find the area of the metal sheet used to make the bucket. So area of the metal sheet will be, first you need to make the curved surface of the frustum of the cone, and then you need to make the circle at the bottom. You don't need anything at the top because it's a bucket that's open at the top. Right, so we need surface area is going to be pi into L into R1 plus R2, recall the formula, plus pi R square, right. So R in this case is the bottom radius, so that's 7 squared. So we need to find L first. You know that L is root of h square plus R2 minus R1 whole squared. So here is going to be root of 24 squared plus the difference of the radii is 14 minus 7, which is 7. So if you do this calculation, you will get 25. So this is going to be 22 by 7 into 25 into 7 plus 14 plus pi into 7 squared. This is going to be 1804 centimeter square. For more revision videos, please like our Facebook page and subscribe to our YouTube channel. Thanks for watching.